Hello viewers, I am Kausalya. Today we are going to solve problem related to superposition theorem. The problem is find the current in the 2 ohm resistor between A and B for the network using superposition theorem. So here we are having, you see, A and B here, there is a resistor between A and B. We are asked to calculate the current that flows through this resistor of 2 ohms by using superposition theorem. So here we are having two sources. So how to use superposition theorem? We have to consider only one source at a time and we have to calculate the current that flows through this 2 amps. Similarly, during the next thing, we have to consider this second source alone and we have to calculate the current that flows through this 2 ohms. And finally, we have to add or subtract depending upon the direction of the current flow. Right. So here, our first step is we are considering only the 10 volt source, right? So we are considering only this source. So here we are eliminating this 20 volt source. So here we are having a circuit like this, right? Now in the same way, the first step is we are going to simplify this circuit. We are going to find the total current that flows through this circuit and we are going to calculate the current that flows through the 2 amps. Right. So here you see in this circuit diagram, this is B and C. Right. So here this node is also said to be the same potential of B here. Right. So this BC, that is this node is also said to be at the potential of B. Right. So this 4 ohm is connected between B and C. Again, this 2 ohm is connected between this B and C. Right. So these two resistors are said to be in parallel. So how to reduce the parallel combination? You see the total resistance is given by R1 into R2 divided by R1 plus R2. So that gives the value of 1.33 ohms. So when you redraw the circuit here, those two resistors are replaced here by a single resistance. Right. So again, you see this 3 ohm and this 1.33 ohm are in series because the current that flows through this 3 ohm also flows through this 1.33 ohm. Right. So how to find the total resistance? Just we have to add. So 3 ohm and 1.33 are in series. Therefore 3 plus 1.33, that gives the answer of 4.33 ohm here. Right. So these two resistors are replaced by a single resistor here. So next, what about the connection of this 2 ohm and 4.33? Are they connected in series or in parallel? You see, these two resistors are connected in parallel. Why? Because you see, the current here, okay, the current entering this node, it gets divided into two. Whenever the current gets divided, then those two things are said to be in parallel connection, right? So here these two are in parallel. So we are finding the equivalent resistance here, that is R1 into R2 divided by R1 plus R2. So that gives the answer of 1.368. Now these two resistors are replaced by this single resistor of value 1.368. Right. So just redraw it. So here comes our final circuit. So again these two are in series, right? So the total resistance is 5 plus 1.368, that gives 6.368. So how to calculate the current? The value of current is given by V by R. Here the V is 10 and the value of R is 6.368. So that gives the answer of 1.57 amps. That is, this is the total current that flows through this circuit due to this 10 voltage source, right? But what we actually need the current that flows through this 2 ohms, right? So when you just go back, you see the total current is, that is the current that flowing from this 10 volt is, it is 1.57 amps, right? But what we actually need the current that flows through this 2 ohm resistance, right? So we can easily calculate, right? So what is the formula? It is total current into opposite resistance. The resistance that is opposite to this 2 ohm is 4.33 divided by total resistance. So 2 plus 4.33, right? So just by using the basic current division rule, you see here, total current into opposite resistance. So the resistance which is opposite to this 2 ohm is 4.33 divided by, right, total resistance is 2 plus 4.33, right. So that gives the answer of 1.07 amps, right. So the current through this 2 ohm resistor is 1.07 amps when you consider only 10 voltage source, right. Next we are going to consider our second voltage source. So when you redraw the circuit, you see here, this is our circuit diagram, right. That is, we are considering only 20 volt source here. So here the 10 volt source is removed. Okay, the rest remains the same. So again we are going to simplify the circuit. We are going to calculate the current that flows through this circuit, right. So here you see this 4 ohm and 2 ohm are again in parallel connection. So we are simplifying this. So when you simplify, the total resistance value is, that is 1.33, right. So here again we are going to further simplify the resistors. You see the current that flowing through this way, it gets divided into 2, right. So these two resistors are parallelly connected. So how to calculate the equivalent resistance? Again, R1 into R2 divided by R1 plus R2. So that gives the answer of 1.43, right. So here we are having this 3 ohm and this 1.33. Okay, these two are drawn as such, and these two resistors are replaced by 1.43 ohm. So it is drawn here, right. Now how to calculate the total current? It is quite simple, right. So just add all these resistors. So the total resistance is, because these three are connected in series, so when you add, you are getting 5.76. So how to calculate the current? The value of current is given by V by R. So 20 divided by 5.76. So that gives the answer as 3.47 amps here, right. Now, but actually we need the current that flows through these 2 ohms, right. So here the total current is 3.47. So here we are having 3.47 amps, right. But actually we need the current that flows through this 2 ohm. So again use current division rule. Total current into opposite resistance. The resistance that is opposite to this 2 ohm is 5 divided by total resistance is 2 plus 5, right. So this is what I had written here. So here finally the answer is 2.48 amps, right. So just look at the direction of the current. So here the direction of the current is like this, right. It flows from up to down. Again, now look at the direction of current for the previous case. So again it flows from top to bottom, right. So the direction of current for this 2 ohm resistor remains the same here. Therefore, by superposition theorem, we are going to add those two currents, right. 1.07 plus 2.48. So that gives the answer as 3.55 amps, right. So here comes the end of this problem. We will proceed with the next one. So the problem is, find the current in the branches A, B and C of the following two source network. Apply superposition principle. So this is our given problem and the branches are A, B and C, right. So one is provided with a voltage source of 4 volt and another one is provided with a current source of 2 amps here, right. Since we are using the superposition theorem, initially we are considering only one source, right. Therefore here we are considering a 4 voltage source. So when you redraw the circuit, here we are having a current source, so the current source is removed, right. So what about the current? Okay, the current will start flowing from here to here, right. Since there is an open circuit, the current won't flow through this 4 ohm resistance, it will flow like this only, because as we all know, current flows through the closed path, right. Therefore the total resistance of this circuit is only 2 plus 2. We should not consider this 4, right. So the total resistance is 4 ohms and therefore the current is V by R, which is nothing but 1 amps. Okay. So this is the current that flows through this circuit, through this path. Right. Now we are going to consider the 2 amp source. So when you consider 2 amp source, here this 4 voltage source in the previous part is removed here. So only 2 amps is considered. So here the current is directly given. Right. So no need to calculate the current. So this is a current source. So this 2 amps flows here like this. So again what happens? The current gets divided between these two resistors. So we are using current division formula. So total current, that is 2 amps, okay, into opposite resistance. Here both the values are 2. So okay, no issues. So 2 divided by total resistance is 2 plus 2. So again this gives the answer as 1 amps. Right. Now we are going to calculate the current through each resistor, that is current through A, current through B and current through C. Right. So first consider current through A. Right. So here again when you look back at this circuit, you see what is the current that flows through this? It is 1 amps. And how it flows? It flows like this, in this direction. Right. Now you consider this circuit. Here the current gets divided like this, right? And through this A part, current flows in this direction, right? So here it flows in this way, whereas here it flows in opposite way. So what happens? You have to subtract. So 1 minus 1, that becomes 0, right? The next thing is current through the branch B. So when you consider current through the branch B, you see in the previous case, no current flows through this part. Okay, because it is an open circuit. Whereas here in this case, this 2 amps current flows through this 4 ohm resistance. Is it clear? Because there is no current division, nothing. This current flows through this. Only reaching this node, the current gets divided. Therefore, the current flowing through this B branch is 2 amps. Right. So this is what I had written here. And the next thing is current flowing through the branch C. So again look carefully, you see here in this first circuit the current flows through this C like this, right? Because current starts flowing from this 4 volt, it goes like this, it comes like this. Again here current start flowing from this current source and it goes like this. So when you consider both the cases, you see current flows from top to bottom and here also top to bottom. So since the current direction is same, here we have to add the values. So 1 plus 1, that gives 2 amps, right? So here comes the end of this problem as well as this video. If you have any doubt, let me know in the comment section. Thank you.